All right, we're going to look at finding the greatest common factor, or the GCF. So what we need to do is we need to find the biggest number that divides evenly into the two numbers that we have. I like to use what I call the cake method, and so sometimes it's not very easy to see the biggest number that you can divide them both by. So I'm going to do an example that kind of breaks that down. Right. So we need to find the biggest number that divides into 14 and 28. And again, that may be hard to see sometimes. So we're going to start by at least dividing them by 2. So 14 divided by 2 is 7, and 28 divided by 2 is 14. Then you can look and say, can I divide 7 and 14 by the same number? And so you can divide both of those by 7. So we'll divide them again by 7. And 7 divided by 7 is 1. 14 divided by 7 is 2. So we can't divide 1 and 2 by the same number, other than 1. And then your GCF is going to be 2 times 7, which is 14. So the largest number that we can divide them both by was 14. And you could have skipped that ladder method step if you could see that easily. So the next question, we have 25 and 35. So we need to figure out what number can I divide both those by. No, it's pretty easy. We can divide them both by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. So this one's pretty easy. Your GCF is just 5. And the next one, 4 and 18. So what can we divide 4 and 18 by? They're both even numbers, so we could at least divide them by 2. And then we have 2 and 9. And then we know that we can't divide 2 and 9 by the same number. So your GCF on this one is just going to be 2. And what number can I divide 27 and 63 by? If you know your multiplication facts, this one's not going to be that challenging for you because you already kind of know what times what equals 27 and what times what equals 63. So you could start by dividing them by smaller numbers, but there again, that's sometimes challenging too. So it's best if you just know your multiplication facts, and what we're going to do is we're going to divide both of them by 9, because I know that 27 divided by 9 is 3, and 63 divided by 9 is 7. And I can't divide 3 and 7 by the same number, so the GCF is just 9. We can follow the same steps, even if we have like variables and we're finding the GCF. We're just going to find the largest integer or number that will divide into the terms. And then we're going to find the largest degree of x. So basically the biggest exponent that we can take out of all of them. So if we look at this one here, we can divide 9 and 45. We can divide both of those. See if I can get zoomed in here. We can divide both of those by 9. 9 divided by 9 is 1, and that x can stay there. And 45 divided by 9 is 5. I can't divide 1 and 5 by anything, so the GCF is just 9. The second one, try to figure out what number can I divide 7 and 21 by. And we could start by dividing them by 7. 7 divided by 7 is 1. Then we've got to bring down the x squared. And 21 divided by 7 is 3 with the x. Now you can look, do both of these terms have an x in common? And how many x's? The first one has x squared, so it has 2 x's. And this one has only 1 x to the first, so x to the first power. So What we're going to do is we're going to figure out how many they have in common. And they only have one x in common. So we're going to take out one x. That would leave you with one x here and 3, and we took that x out front. So our GCF is going to be 7x. You can always check yourself if you want by multiplying that 7x as your GCF times what you have in your bottom row right here. And we have an x and a positive 3. 7x times x is 7x squared, and 7x times 3 is 21x. And that should match exactly what we started with. All right, the next one, we can divide both of those. Let's divide them both by 2 just to see what we got. 16 divided by 2 is 8. And 12 divided by 2 is 6. And then we can divide both of those again because they're even numbers. So we're going to divide them by 2 again. 8 divided by 2 is 4. And 6 divided by 2 is 3. So our GCF is going to be 2 times 2, which is 4. And then we need to look at our variables. So the first one has x to the 6th, and this second term has x to the 3rd. So they at least have 3 in common. So we're going to take out x to the 3rd. Oh, goodness. So we're going to take out x to the 3rd, which would leave us with 4x to the 3rd and just 3 because we took all 3 of those x's out. So your GCF is 4x cubed, or 4x to the 3rd. 2 more here. All right. We're going to try, but we're just going to look at them. We cannot divide 13 by any number. It is a prime number. But we need to look and see, do these terms have anything else in common? Well, they both have an x. This one has x squared, and this one only has 1x. So we can actually take out an x. We can factor out an x. So you would be left with 13 and only 1x there, and then just the 6. So your GCF on this one is simply an x. That's all you can factor from both of them. All right, and last but not least, we need to figure out what can we divide all 3 terms by. So we can divide all 3 of these terms by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. And 55 divided by 5 is 11. 11 is a prime number, so we know we can't divide the coefficients or the numbers by anything more. But we do need to check on our variables. So we know that this one has 3 x's, 2, and 1. So we are going to at least remove 1 or factor 1x out from all 3 terms. That would leave you with 3x to the 2nd. We're just going to subtract 1 because we take it out. 5x to the 1st, or just 5x, and then that one is just going to be an 11. So your GCF on this one is 5x.